A polynomial is an expression consisting of many terms. Okay. Now, typically when we refer to polynomials, we do refer to stuff that has a bunch of terms in it. But when we're talking about polynomials, we can also talk about things that don't have many terms in it. So, 5 is considered a polynomial. Negative 6x is considered a polynomial. 4x squared minus 3 is considered a polynomial.
What is consisting of many terms?
It just means typically polynomials are made up of many individual terms added together. But it doesn't have to be a bunch. It can be one term.
What terms are 5 made out of?
5.
That's all?
It's a term, yeah. Okay, now 3x squared minus 2x plus... Let's actually make that 3x cubed plus 2x squared plus 7x minus 5. So it has 4 terms. Okay? Polynomials are basically a string of terms added together. And it can just be one or it can be a lot. One of the hallmarks of a polynomial, though, is that you will only ever have positive exponents out there. You won't ever have negative exponents. Why is this chair so squeaky? It's driving me crazy.
I'll get you a new one.
All right, now, we are going to have to write polynomials in standard form, okay? What it means to write it in standard form is 2 pieces, okay? So typically, we're going to look at polynomials with one variable, but sometimes we look at polynomials with multiple variables. When we look at multiple variables, we have to make sure our polynomial is written in alphabetical order. So the first thing we're going to put is must be in alphabetical order. In addition to being written in alphabetical order, our exponents have to go from biggest to smallest, okay? So we're going to start with the highest exponent, or we do it with highest exponent first. So if we only have one variable, all we worry about is putting our exponents in descending order, so biggest to smallest. But if we have alphabetical, we put it in alphabetical order, then we go in and put in descending order, okay? So I want us to go ahead and look at the first section. I'm going to go over 1 through 5 with us, then I'm going to have you do 2 through 6. So, yes. All right, so for number 1, okay, the term with the biggest exponent is what? What is the term with the biggest exponent? 2x squared. So we're going to say 2x squared first. Then I'm going to go to the term with the next exponent. Technically, the exponent on x is what?
1.
So we would do plus 3x plus 1. So all we do is rewrite it so that our exponent goes from biggest to smallest. If we have a constant, that goes at the end.
So you don't solve nothing?
No, we're just rewriting it in standard form. All right, for number 3, okay, we're doing the same thing. So what is the term with the biggest exponent for number 3?
Okay.
We have the w to the third. Then we have 5w squared. What comes next?
Negative w.
Negative w, then plus 28. Now, number 5 is an example of where we have multiple variables. Okay, so when we do this, which comes first, A or B?
A.
A. So what we're going to do is we're going to put A in order of biggest to smallest exponent.
So A3.
So we're going to start with A to the third. Then what term does A have the next biggest exponents in?
5A.
So we do 5A squared, B squared. What is the next term for A?
2A.
Plus 2AB. And then we're going to put negative 2b to the third. So A is, since it's alphabetically first, that is the one we do our exponents from biggest to smallest in. All right, now I want you all to do that same thing with 2, 4, and 6. Do that for me real quick. Just put them in standard form.
Multiply by a fraction, but not dividing. Multiplying by a half and dividing by
2 are the same thing. For number 2, which term goes first? Then what should I put?
K2.
K2.
Do I just put K2 or
Plus,
okay?
minus K, then plus 64.
Perfect. All right, then we're gonna do number 4. So for number 4, what do I do?
Negative 3 n.
N to the third.
Oh yeah,
Plus n.
plus n.
Plus 24.
All right. Number 6.
Negative 3. I mean negative c to the third power.
Minus 7c 2d 2
Plus 5b3.
plus 5b3 plus 13.
Perfect. That is how we put them in standard form. That is all we got to do. All right. So what we are going to do now is we're going to actually talk about how to classify the different polynomials that we can have. So to do that, one of the things we're going to look at is the degree. So the degree is a fancy way of saying what is the highest exponent. So if I look up there at question 1, what is the biggest exponent? 2. So the degree of that polynomial is 2. For number 3, the degree of that polynomial is 3. That's my biggest exponent. For number 4, the degree is also going to be 3 because that's our biggest exponent. That's how we find the degree. So you just look for whatever the biggest exponent is. All right, now, to classify polynomials, okay, we look at their degree and the number of terms we have. So we're going to start with degree. So if your degree is 0, that is when you have a constant. Which just means you have just like a number, like 7 is a constant. That is a degree of 0. The reason for that is because if I was to say 7x to the 0 power, what is anything to the 0 power? 1. So that 1 basically just makes that 7 times 1, which is 7. So it's because when we do a 0 power, it causes anything that's being raised to go away. So if we had an x there, it would go away because it's got a 0 on it. Now, for our degree of 1, that is a linear function. And that occurs when we just have a plain old x. Or like 5x, 8x, negative 72x. All of those have an exponent of 1, so they're linear. An exponent of 2 is called quadratic. We are going to spend a good chunk of time looking at quadratic equations. I think that's pretty much our next 2 units is quadratics.
Not coordinate 4.
Well, not, no, like a quart means, like if it's quartic, that's 4.
Like quadrilateral.
I don't know. I'll have to look into that. And so an example of that would be like x squared. Okay? Then for a 3, we're going to have cubic, which is x to the 3rd. Yes. Yeah, that's fine. It's on Schoology. All right, so for number 4, we can have quartic. Now, this can keep going, like x to the 5th would be considered to be a quintic polynomial and so on. But we aren't really going to focus on ones outside of that. Honestly, we're not really going to look much past cubic. The thing about polynomials and why the degree matters is because the degree is going to determine what the ends of the polynomial are doing, like which direction they go. So like if you have a linear function, it's like a straight line, right? It looks like this. But if you have quadratic, it makes a U. If you have cubic, it makes like a little zigzag shape. If you have quartic, both ends go up and it can do some weird stuff in the middle. If you have quintic, it's going to flip back down and you're still going to have some weird stuff. But the degree determines which way your ends of your polynomial get flipped, right? And it changes the shape of what they look like. That's why degree is important. And degree also tells you how many solutions you can have to a problem. So that's why it's important. Now the number of terms is just exactly what it is. It is how many terms is in the problem. So if we have one term, it is called a monomial. Monomial. Now, in the same way, how many people talk in a monologue, Stacy? One. Just one person talks in a monologue. It's just one person, like, talking. It's like
autobiography.
No, it's like. So you know in like a movie when someone like the main character just like starts talking and like has this whole little spiel, they talk and they're just them talking. That's kind of like a monologue, right?
They're talking until this.
Yeah, kind.
Like at the beginning of the episode, like she'll start talking. Somebody will start talking, and they're just talking.
Yeah, pretty much. But like it's just one person talking because mono means one. Okay, so a monomial. Because y'all, please, conversation back to math. Okay, so a monomial is only one term, so like 3x to the 7th. And you are right. Then when it's 2 terms, it will be binomial because bi means 2. Yes. Look at you. And then we have a trinomial because tri means 3.
I thought 2 would be like die.
That's in chemistry.
Yeah, in math we use a binomial. And so in trinomial we can have like x squared minus 5x plus 7. But when we have 4 or more terms, we will strictly use the word polynomial because poly means many. Yes, ma'am. So it has 2 terms. It has 3 terms. That's all it means. Is it's literally just 1 term, 2 terms, 3 terms, or 4 or more. Now we can use the term polynomial to describe any of those. Okay? But we have to use polynomial to describe when it's 4 or more. Okay? We'll spend a lot of time looking specifically at quadratic trinomials this unit and looking at factoring them. Okay, that is a big chunk of what we're doing. So that's kind of why it's important for us to know the difference because being able to recognize which type of problem it is will give us certain strategies for solving those problems. So what we're going to do is we're just going to name out what these are. So what is the degree of 7?
Degree of 7, 6.
What's the degree of number? 0, right? Yeah, so that means it is a constant. How many terms did you say?
1.
Yep. So it is a constant monomial. Now, when we're looking at number 9, we have 7p plus 1. What is the exponent on p?
1.
1. That makes it
Linear.
linear, and then it is going to be a binomial because it's 2 terms. So we have a linear binomial. Then number 11, what's the biggest exponent on number 11?
It's a cubic.
Yep, and how many terms has it got?
2, so it's binomial.
So it is a cubic binomial.
I spelled cubic wrong. So.
How did you spell cubic?
I spelled it with a Q.
Oh. I mean, technically,
It's not wrong.
cubic. All right. I want y'all to do 8, 10, and 12 for me real quick.
I don't know if it's x minus 7 or linear. No, because it's linear. Well, but the x has a 1. Oh, like this one. Okay. It's like right next to it. I think it's mine. Who's talking?
What? Yeah, it's linear.
Yes.
It would be. Alright.
Okay, you only got one term then. So if it's just one term, it's going to have.
It'd be linear binomial.
Are what?
Terms are how many things are being added together.
Oh. So what is green?
That's your highest exponent.
Added and subtracted?
Yep.
Is
So constant is just going to be a number. Any number. Whereas linear is going to be a number and a
what is the
All right. Number 8. Okay, number 8 is what?
Linear monomial.
It is a linear monomial. Okay, then number 10 is a what?
Quadratic.
Quadratic trinomial. What is 12? Perfect. All right. So that is our classifying polynomials. So now I want us to switch.
Alright, that's the notes for today, right? Yes, we do.
All right, now let's go to the back. We are not done,
I think we
Stacy.
should take it slow, so.
It is going to be a chill day, but like it's not hard. It's just we have to get through the easy things. All right. So, adding and subtracting polynomials. So, yes.
Oh, you can't put X in a calculator.
You think I like poison?
Maybe.
Well, it doesn't count as.
I love animal crackers though. All right. Adding and subtracting polynomials. This is literally the exact same. Is like combining like terms, except we're just looking at two separate polynomials being combined. So let's look at here. For adding, when I add things, if I say plus -7, what is that the same as saying?
Plus -7.
Minus 7, right? Whenever we add, our signs don't change. So this right here is the same thing as us doing 11x minus x squared plus 13 plus 2x squared minus 23 minus 5x.
Wait,
Literally.
It's just nothing changes. We're just adding.
Nothing changes when we add, okay? And so what we are going to do,
Then what's
the best way for us to go about this is because it's showing you this is a polynomial and this is a polynomial, and we're adding the two polynomials together.
So we're adding 2 trinomials.
All right, so when we look at this, all right, we are going to be specifically trying to, we have to answer into standard form, right? So because we answer in standard form, we're going to start with whatever has the biggest exponent, okay? So what is our biggest exponent we have in this problem?
2.
2.
Yeah, 2.
So I have negative x squared and also what?
You have 2x, 2.
If I combine those two together, what do I get?
You get
What is negative x plus 2x?
it,
Be x squared. All right, now, the next term would be our term with just a plain old x, right? What are those terms?
11 and 35.
What is 11x minus 5x? And then our next term will just be terms with our constants. So it would be 13 and negative 23, which is what? Negative 10. So we would look at 13 and negative 23, and we would get negative 10.
we have a quadratic trinomial.
It is a quadratic trinomial. All right, now, when we look at subtracting them, okay, when we subtract, we have to make sure we distribute that negative sign to each term. Because when we subtract, it can change sign. So we have 4x squared plus 5x minus 7x minus 3x squared and minus 1. We have to distribute that negative because when we subtract, we are changing our sign. And we have to be really careful because if there was already a negative in that problem, when you subtract a negative number, what do you have to do? You have to add them, right? So you have to pay real close attention when you have that negative because you have to make sure you change your signs. Now we do the same thing. So our first term, we're going to find using what?
Just combine it.
Yeah, what do we need to combine first?
4x squared and 3x negative.
What is 4x squared minus 3x squared?
X squared.
Does the square ever go away? I don't think so.
Not when we're adding and subtracting now. All right. So what do I do next?
You gotta do your x.
Yep, 5x minus 7x, which is?
2x, negative 2x.
Then does negative 1 have any friends down there at the end? No, it's lonely. It's sad. So we're just going to bring down negative 1 all by its lonesome. Yes.
Quadratic.
All right, that is also another quadratic trinomial. Okay, so now we're going to look at the rest of these examples. We're going to do half together, and I'm going to let y'all do half by yourself. So for the odd ones, we're going to go over them together. So this is addition. So do our signs change when we add? No, we just bring them down. Okay, what like terms can I combine? X and 4x to get what? What else do I need to combine?
Negative 2.
What is 5 and negative 7?
Negative 2.
Perfect. That's what we get for that
Do
one.
we have to name them?
No, you don't have to name these.
Are we doing 14 now? Or 15?
We're going 15. We're doing all the odds together, and y'all are doing all the evens.
What, for like homework?
No in class. All right. For 15, again, we're adding. So do our signs change at all? Nope. So I just bring everything down. What like terms can I combine? But before that, what do I have to do first? W to the third. Does it have any friends? So we just bring it down. We go from biggest exponent to smallest. So now I'm going to look at the squared term. So you said negative 2w and which is what when I combine them?
Just W.
So what would I put, plus or minus w squared?
Plus.
Then to get the next term, what would I do? Which gives us? Perfect. All right, 17. We're adding again. So we're going to have 8 minus p squared plus 5p plus p squared minus 15 minus 4p. What's the biggest exponent term?
2.
So negative p and p squared. What can I do with those two terms? They cancel. They become 0. So do I need to put 0 p squared?
No.
No. What would my next term be, though?
It's just p, 5p and negative 4p.
Which is going to give us...
1p is just p.
Then after that, what's my next term?
8 minus 2.
Which is negative 7. All right, 19, we have to subtract. So I have to pay careful attention. I'm going to distribute that negative. So I get x squared plus 17x minus 3x squared minus 5x. So what do I need to start with?
Your 2x minus 3x squared.
Or x squared minus 3x squared is what? Positive or negative?
Negative.
Negative 2x squared. Then what do I do after that? What is 17x minus 5x?
12x plus 12.
And then we're going to do 21. So for 21, we are subtracting again. So make sure we distribute that. So we get 4c minus 11 minus 4c minus 11. No, does it? What cancels? Yeah, 4c and negative. Those two cancel out. But negative and 11 and negative 11 give us negative 22.
Which is
Okay, when you say negative 11 minus 11, that gives you negative 22. The only time you will change signs is if you're saying negative 11 minus negative 11. That is where that would become positive. All right, so I want y'all to do, oops, we have one more. Okay, let's do the 23 together too. So I'm going to distribute my negative, and I get 7v minus v squared plus 14 minus 15 minus 8v minus v squared. Now what? What's my like terms?
negative v2 and negative v2.
When I combine those, what do I get?
Negative 2v squared.
Stacy, what's your question? You don't have a question anymore? All right. So our next one, what do I combine next?
7v and negative 8v.
When I combine 7v and negative 8v, what do we get?
Is negative v.
Then what do we combine last?
14 and 15.
What is 14 minus 15?
Negative 1.
That's all we do. Okay. So I want y'all to do the even ones of these.
Is that all we're doing?
No. We're adding and subtracting. Chill out.
So much work though.
It is boring, but we do need to do it to make sure we know how to do it. Yes, ma'am. Yeah. What was your question you had?
No, like, trying to see if I'm still remembering it right. Yeah, I'm just thinking about
Whenever you're adding and subtracting,
$100.
your exponents will stay the same.
I'll pinch it.
So we have negative 1b minus
25
1b.
cents.
Whenever you're adding.
That's all I have.
Actually, no, I'm not wallet.
Thank you, negative. Oh, wow.
How did your game go last night?
We won 16.
Hey. Hey. Get out, bro.
Are you doing this finish?
Oh.
So like now I know what I need to put on my card. Can I come back tomorrow and finish this test?
Hey.
I need to put some stuff on my card that I really need.
Well, I take this card though.
Yeah.
Put it on a tiny little card. Put it on a tiny little small card. We don't have much. But I have to take this card.
I can't make a really and do it out loud. work on that a little bit more, but because I think I
What happened?
what I need.
Oh, snap. What's wrong? Can't continue the lesson.
So weird.
Hey?
Yes. Yeah. All right. So I'm going to go through and make my answers real quick. Y'all continue working. RS, yeah.
Yeah, Edwin Daniel, forward. That's what he did. Okay, Edwin
What did he do to deserve the full name?
He's trying to pull my desk back again so I can fall again. This would be like my third time falling.
We try and get like.
Oh my god, Jackson, shut up.
Yes.
I have so much homework.
I bet.
I have course test, math test, some not.
Yes.
Presentation.
I wanna compare test rates.
How many weeks?
Wait, you didn't do test rates?
I just missed 4 days. I missed Thursday, Friday, Monday. But I'm in HS and I got presentation this week. And if she tries to be interested, then maybe you'll try. I got literally just in it today.
I'm not adding chemistry. He doesn't know anything. After you can make him fall out of this You just not honest at this point, like not doing it either.
What is this? What am I supposed to do?
All right. Number 14. Is this what we got? If I messed up on one, I did them in my head, so just let me know. All right. 16. 18. Yes. 20. 22.
Yeah.
24.
Wait, I was confused
On this one?
Yeah, because
So you don't get this?
when you changed it for your y, you got negative 2y, and you had the negative 3y.
So-
it'd be negative 3y minus negative 2y, right?
Yeah. I did make a typo on this one. When I make that negative, then I do that one. It has to become positive because it's already negative. Minus 5x.
Why would you get negative 5y then? Wouldn't it be negative?
Well, let's look at it. Let's look at it. Let's look at it. Let's check my work. So we did our like terms. We would have 8x minus 5x to get 3x. Then we would do negative 3y minus 2y. So it's already negative 3 and it's got to back up 2 more. So it'd be negative 3, negative 4, negative 5.
I thought it was
Which is
negative-
where that comes from.
Can you go back up to
Wait, so it's not negative 3y minus negative 2y?
No, because over here, do you see how, oops. Do you see how, ooh, goodness gracious. That 2y is positive to start with.
Yeah.
So when it becomes negative, we just say negative 3y minus 2y.
Wait, so why is
It is plus 13. That is my bad.
Okay, I did that.
I was gonna say, why is it negative 13?
That was just my typo. All right. Which other one did I need to go back up to? 18.
Actually,
All right. For this one, okay, we start with r to the third. We bring it down because it's not got any friends. Then for 6a squared, we bring it down because it also doesn't have friends. But we do have negative 5a plus a to get negative 4a minus 5 more a, which gives us negative 9a. All right, so yep. And so what I want us to do is I want us to go ahead and look at the examples for the next page, just because I want us to go ahead and kind of think about it. This is, again, stuff we have done before, okay? We are multiplying a monomial and a polynomial.
What page is it?
The next page. And so whenever we do this, you have to remember the product rule for your exponents, which just means when you say x to the m times x to the n, what do I do with those exponents? Add them. That is the key thing to remember there. That is the rule we got to make sure we remember, okay? And we're just going to do our examples real quick. That's all we're going to work on today this morning. That's plus n. I'm losing my mind today. All right. So for example 1, I have to distribute that x. What is x times x?
Wait, can you go back over?
It is x squared. I will in just a second, Will. And then what is x times 4? 4x. So that is all I would have to do for that problem. Okay, and I know that because x to the 1 and x to the 1. So we say 1 plus 1 is 2. And we use the product rule to do that. Yes. All right. Now, we are going to look at example 2. Okay? Example 2 is a bit trickier. Okay? So as we look at this, we have to distribute first here. What is 5 times 3? 15. That's the first thing we got to worry about. Then I have m to the third and m squared. It's going to give me m to the what?
6.
I have to add exponents though, Ramsey. M to the 5. Because 3 plus 2 is 5. Then we're going to do the same thing here. What is my next term going to be? What is the exponent on this m? Yep, so we got to add those so we get 4. And then last but not least, what are we going to have? Five times negative 7 would be... Now, does this one have an m on it even? It doesn't, right? So there's no m, so we just bring down m to the third. And that is when we're gonna do tomorrow. Okay? So we are good now. Yes.